Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X Object 3 times the size of the Sun. Now, in Article 259, entitled Large Planet X Object and Debris in the Inner Solar System, an object appears in a stereo A chord 2 image, which is again shown here. I have stated that from a size comparison with the Sun, the object has to be about 3 times the size of the Sun. But there are those who doubt this, stating that the object must be a lot closer to the detector than to the Sun, and therefore is not even close to that size. So in this article, I'll carefully detail the logical process behind my estimation of the size of this object. As you can see, it looks huge, and just an eye comparison of a rough estimate. This is what I used here, comparing it with the size of the Sun as indicated by the white circle on the occulter. It seems to be at least 3 times the size of the Sun. And this is a stereo A chord 2 image from September 13, 2017, in which this object appears actually within a CME. And so, first of all, the object is seen within a CME shortly after the CME has left the Sun, which places the object within the Sun's outer corona. In addition, the detector is designed to view CMEs within the Sun's outer corona. Beyond the distance as defined by the outer edge of the Sun's outer corona, the CME material is too dispersed and cannot be detected anymore by this detector. This means that this object has to be inside the Sun's outer corona. And here we have a graph that defines the distance between the Sun and the Earth. And it's given in terms of astronomical units, where 1 AU is the distance between the Sun and the Earth. So 1 AU stands for 93 million miles. Now you can see Mercury's position is about 0.4 AU, so 40% of the distance between the Sun and the Earth. And here we see this is the diameter of the Sun, and the Sun's diameter is 864,000 miles. So this is about 0.01 AU. And here what is indicated is the outer edge of the Sun's outer corona. So that's indicated by this red line here. The Sun's inner corona is indicated here, but we're not using it in this article. So the Sun's outer corona, the radius or the distance between the Sun and its outer edge is about 12 times the radius of the Sun. So that's 5.2 million miles, which is about 0.06 AU from the Sun. Now, 0.06 AU is 6% of the total distance between the Sun and the Earth. And don't forget the spacecraft, the stereo A spacecraft is in an orbit which is very close to the Earth's orbit, so it's therefore 1 AU from the Sun as well. So the fact that it's 0.06 out of 1 means we have a 6% uncertainty in a direct size comparison between the object and the Sun. So what does that mean? It means that if the object is at the closest possible distance to the detector, it can only appear to be 6% larger than it would be if it was exactly at the same distance as the Sun. So if it's side by side with the Sun, then a size comparison would mean that it would be an exact. But if it's at the edge of the outer corona in front of the Sun, it can only be 6% closer to the detector than it would have been if it was side by side with the Sun. So this would mean that a size comparison would make it appear larger by 6%, which means that its real size would be 100 minus 6, which is 94% of the size we estimate, which is 3 times. So if we multiply 0.94 by 3, we get 2.8. And so it would mean that it would be 2.8 times the size of the sun. But again, this is a rough estimate, so we would immediately round off the value to 0 decimal places, and we get 3 again. So if we do a more accurate comparison, because this is a very rough estimate that I did here, so we can actually do a more accurate comparison. And what we do is we draw a circle that's the same size as that occulter, and then we place them side by side in order to estimate the diameter of the object. You can see at least 4 of these circles fall within the diameter of this object, which means that a more accurate estimation of its size would mean that it's about 4 times the size of the sun, not 3. So when I estimated it to be 3, I was already being conservative in my estimate. Now, again, the uncertainty in this measurement would be 6%, which means that its minimum size is 0.94 times 4, or 3.76, which again rounds up to 4. So in conclusion, stating that the object seen in the stereo core to image featured in this article is 3 times larger than the sun is not an overestimation of its true size, but it is actually an underestimation, since it can be argued that the object is in fact 4 times the size of the sun. And here is the reference. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.